Angles and triangles. All angles can be classified as acute, right, obtuse, or straight according to their measures. So let's look at each of those types of angles. An acute angle is less than 90 degrees. We remember that 90 degrees is a right angle, which is like the corner of a piece of paper or the corner of a square. So an acute angle is smaller than that. Here's two examples, a 35-degree angle and an 80-degree angle. One tip is to remember that if you didn't have the degrees of this angle and you needed to figure out if it was acute or right, because it looks sort of like the edge of a piece of paper, the corner of a piece of paper, you can use something that is a piece of paper, or note card is a good thing to use. I'm going to use something so that you can dark so you can see it. But if you place that right in the vertex of the angle, you can see that the red line, the top red line, does not go right along the edge of this square. So that means that this is less than a 90-degree angle. So it's an acute angle. A right angle, of course, is 90 degrees, and it is marked oftentimes with this box, a small box. An obtuse angle is bigger than 90 degrees, but less than 180 degrees. So here are two examples. A 140-degree angle, you can see that it's nice and wide. And a 100-degree angle, again, you could prove that this was not a 90-degree angle by placing the corner of this square on one of the lines, also touching the vertex. And then if you can see this white space right here, that tells you that it's wider than the corner of a piece of paper or the corner of a square. So this would in fact be an obtuse angle. It's bigger than 90. And finally, a straight angle is exactly equal to 180 degrees, or two 90-degree angles put together. You can see that it's like this was closed and opened all the way up to be flat out or straight. So this is a 100-degree angle here. We can take what we know about angles in order to classify triangles by their angles. Triangles can be classified as either acute triangles, right triangles, or obtuse triangles according to the measure of its largest angle. So whenever you look at a triangle, you look and find its biggest angle, and that's the name that you give it. So let's look at a couple of examples. An acute triangle has three acute angles. It doesn't have anything bigger than an acute angle. So its biggest angle is acute, so we just call it an acute triangle. So this triangle here has all 60-degree angles. Each of those is less than 90 or acute, so this is an acute triangle. Here we have one with an 80-degree angle and two 50-degree angles. All of those are less than 90, so this is an acute triangle. A right triangle, like we've learned in our area video, has one right angle. We can see the right angle here and then two sides of 60 and 30. Since this is the biggest side, we named this triangle the biggest angle, we named this triangle a right triangle. And here we have another right angle with the other two angles being 55 and 35. Since 90 is the biggest angle in this triangle, we call this a right triangle. Both of these having one right angle. And finally, an obtuse triangle has one obtuse angle. We can see here the obtuse angle, and this one is 140 degrees with two acute angles opposite that. And this is the biggest angle, so we call it an obtuse triangle. Here we have a angle that's just a little bit bigger than a 90-degree angle, but it still is an obtuse angle, and two acute angles. Since this is the biggest angle, we call this an obtuse triangle. Not only can we classify triangles by their angles, but we can also classify them by their sides. Triangles can be classified as either equilateral, isosceles, or scalene according to the number of sides with equal length. So let's take a look at what that means. An equilateral triangle, it names it by its sides, and that is a triangle in which all sides are congruent or equal. So we can see in this triangle that each side is 5 inches, so we would call this an equilateral triangle because all sides are congruent. An isosceles triangle has just two sides that are congruent. You can see here that this triangle has two sides equal to 9 centimeters each, and then one shorter side of 5 centimeters. So this is an isosceles triangle because two sides are congruent. And finally, in a scalene triangle, none of the sides are congruent. Every single one is different. So we have a 5-inch, a 3-inch, and a 6-inch, making this a scalene triangle. I hope that you notice these triangles that do not have lengths measured on the sides, but there are marks there showing you, giving you information about the sides. This triangle has one mark on each side, and that tells you that they are all equal. In this triangle, these two sides have the same mark, just one short thick line, and this side has two lines. That's telling you these are the same because they're marked with the same amount of small lines, and this line segment is different. In this triangle, we can see one side, another side, and a third side. Each is marked with a different number of small lines. This is telling you that each side of this triangle is a different length, making it a scalene triangle. So that was a lot of new vocabulary. Let's see if we can come up with a couple of ways to remember some of those words that might be tricky. Anytime I say the word acute for acute angle, remember an angle smaller than 90 degrees, my brain thinks acute little angle. And I say it in a high voice and remember that it's a small little angle. It doesn't mean small as in the length of the rays, but small as in the measurement of the angle. I like to then on the opposite side say the word obtuse with a big low voice to remind me that it's a big angle. So remember a cute little angle and an obtuse angle. When we talk about triangles and the so you can use those hints for the classifying triangles by angles. When we talk about triangles by their sides, and an equilateral triangle almost has the word equal in there, and that tells you that all sides are equal. So that's a pretty easy one to remember. The isosceles, I found two tricks that might help you. The SOS in isosceles, you could think about side, other, side, to show that it has a side, another side that's different, and a side that's equal to the first side. So two equal sides and one different side. Remember, though, that it's possible to have two long sides that are the same and one short side. In this case, two long sides and one short side. But it's also possible to have the opposite. These two sides here are short and the other side is long. So we could write this also with the small s, big O, small s. If side, other side doesn't help you, or you want another hint, isosceles, I spelled that wrong, need a little extra s there, but isosceles can stand for is symmetrical, because each of these triangles, isosceles triangles, can be divided with a line of symmetry because these two sides are equal, making this half and this half of the triangle equal. Isosceles. There we go. And finally, a scalene triangle. It might help you to look at the last two letters of the word scalene and let the N and the E stand for not equal, because none of the sides of a scalene triangle are equal. So I hope some of those clues might help you remember our new vocabulary about triangles and angles.